Alright, so in this video I'm going to show you how to find the area between a curve and the x-axis. So this question gives us a diagram and it also gives us the equation of the curve y equals 5 minus x squared minus 4 over x squared, and we want to find the area enclosed between the graph and the x-axis. Since it gives us a diagram, we know we want to find this area here. Okay, so the first thing that we need to do is to find out what these points are so they can be our limits. So to do that, we want to find the places where y equals 0. So we want to solve this equation, so we want to find the roots of this. So to do that, obviously we've got a x squared on the bottom of a fraction, which is going to be difficult for us, so what we should just do is multiply everything by x squared first of all. Now x squared times 0 is going to leave us with 0. That one is going to become 5x squared. That one is going to become minus x to the power of 4, and that one's going to become minus 4. Okay, and now we have an equation that is actually quadratic in x squared. So what I mean by that is we can actually replace, to make this easier, we can actually say y, well maybe y isn't the best thing because we've got it up here. Let's say z equals x squared, and if we put that in here, we're going to have 0 equals 5z minus z squared minus 4. And now that looks like a quadratic equation that we'll be able to factorise and solve. So let's do that. So let's multiply everything by minus 1 to make it a bit easier for ourselves. So we're going to end up with minus 5z plus z squared plus 4. Put that back into a nice order. Okay, now that's what you would expect to see when you're solving a quadratic. That's the way around you would normally have it. So let's factorise this. We want two things that are going to multiply to give minus 4, positive 4 rather, and add up to negative 5. So that's going to be minus 4 and minus 1. So that means that z equals 4 or z equals 1. And now we need to remember that z was actually x squared. And you could have done all of this by factorising directly from here. I've only done this just to demonstrate to those of you who might not be completely comfortable with this idea of a quadratic in x squared. So we need to remember that this means x squared equals 4, x squared equals 1. So x equals 2 and x equals 1. Okay, now we know it's the positive values because of the graph. Okay, yes, this could be plus or minus 2 normally, but we can see on the graph that it's the positive values of x that we're interested in. Okay, so we can now say, right, we know this must be 1 and this is 2. So we want to find the area under this graph between 1 and 2. So what we need to do now is integrate. So the area is going to be the integral between 1 and 2 of this 5 minus x squared minus, and I'm going to write this now as 4x to the power of minus 2, just so that it's easier for me to integrate it. Okay, and that's with respect to x. So first step, I need to integrate this. So I'm going to, since it's a definite integral, I'm going to have it in square brackets. So the first term there, 5, that's got an x to the power of 0, so we're going to increase the power by 1 and make it 5x. We would divide by the new power, but that's just 1, so it has no effect. This next one, we have minus x squared. We're going to increase the power by 1, which is going to give us 3. Now we need to divide by the new power, which is going to give us a third over there. Next one, we've got x to the power of minus 2. Increasing that by 1 is going to give us x to the power of minus 1. Okay, lots of people might accidentally change it to minus 3. But remember, minus 2 plus 1 is actually minus 1. Okay, now we're going to divide by minus 1, so the 4 is still the same, but we're going to change that sign there to a plus. Okay, and now we're finished with that. We close our square brackets and we put our limits on there. Now, to evaluate these limits, we want to substitute into all of this. We want to substitute the upper limit in. So we've got 5 times 2 minus a third 2 cubed plus 4 2 to the power of minus 1. And then we're going to subtract from that what we get if we substitute our lower limit 1 in. So it's 5 times 1 minus a third 1 cubed plus 4 times 1 to the power of minus 1. Okay, and now this is the all you need to actually write down. From here you can directly just put this into your calculator and work out the answer. So I'm going to do that now. So 10 minus 1/3 times 8 plus 2. So that first part should be 28/3. And then let's work out what the second part is. So 5 minus 1/3 plus 4. So 28/3 minus 26/3, we are going to be left with 2/3 units squared, and that is our area.